Okay, and this one right here, these are just some paperclip examples and safety pin examples, very famous examples. Students come back years later and tell me how fun they had solving these problems. It's really going to change your life. So we're going to find the scale factor of the dilation, then tell whether the dilation is a reduction or enlargement. So, of course, when we're doing math, it's good to use common sense, but I'm going to be very thorough, very detailed, write down a lot of stuff right now, just so it's clear what my thought process is. All right, so we always want, when we do the scale, all right, so first off, scale factor. Now, you guys probably noticed I'm really bad at spelling. I hate writing words. We call this SF. All right, scale factor is SF. All right, so when I write that in the future, technically sometimes you might see it written as K or even D for dilation. Why do they use K? I have no clue, but I like to write SF. All right, so the scale factor is the final length over the original. All right, and this is why prime notation is so important. Like from C to P prime, we know that's the final one. All right, it's going to be from C to P prime, and the original one is C to P. All right. So when I want to find the scale factor, I do my final length 12 over my original 8, and then I just reduce. All right. So this becomes 3 times 4 and 2 times 4, factored out of 4, and it just becomes 3 over 2. All right. So again, that's a lot of writing. If you just wrote 12 over 8 and 3 over 2, yeah, I get it. All right. But our final, original, I'm going to be writing all that stuff out right now just because it's a new skill. And when you do something new, we want to be very thorough. All right. And also we forgot to write, so 3 halves is bigger than 1, so this is an enlargement. Again, use common sense. That's something I like about geometry. It's a lot of common sense. Same thing over here, scale factor. It's going to be final over original. So what's the final length? 30, or let's even write C to P prime, C to P. All right, notice how the final length C to P prime is 18. All right. And then the original length was 30. All right, kind of running out of room. So 6 factors out of both of these, it's 3/5. All right, so the scale factor is 3/5. That means it's a reduction. All right, so now let's just practice coordinate notation for a dilation. All right, so we did some just in space, just chilling. Now we're going to do it in a coordinate plane. All right, so there's a bunch of ways to do this. Like one way is, this is my favorite way, is this. Let's look at A. The coordinates of A is 2, 1. Let's look at the coordinate of A prime. A prime is 6, 3. All right, so like, what am I multiplying by? What's my K? It's 3. Oops, wrote a weird 3. It's 3. That's one way. That's the most famous way. You could actually count lengths too and say, well, AB is 3, A prime, B prime is 9. How do you get from 3 to 9? Times by 3, whatever that may be. But remember, the coordinate notation, I'm writing this again, is XY arrow, KX, KY. It's multiplication. Remember, oversimplifying, if I could use one word to summarize this unit, it's multiplication. All right, don't you forget that. All right. Same thing for this one. Let's just keep knocking out more examples. A is at 2, 1. Actually, this one's a little bit, A's a little bit goofy. It kind of falls, it's not exactly at, notice how it's not exactly at 2, 1. Me had a little brain fart. Let's actually look at B, because B falls perfectly on a coordinate grid both times. B is at 1, 2, and 1, 2, 3, 4, 4, 8. Okay, so what am I doing? What am I multiplying each coordinate by? 4. So just X, Y, arrow, 4x, 4y. And these all turn out to be enlargements, but that's okay. A is negative 2, 2. A prime is negative 4, 4. Again, this holds true for any pair I pick, but again, just another scale factor, and this one is 2. Alright, now we're actually going to perform some dilations in a coordinate plane. Alright, the vertices of the quadrilateral K, L, M, N are all this junk, so let's go ahead and plot this bad boy real fast. We're going to have negative 6, 6. L is negative 3, 6. M is 0, 3. And N is negative 6, 0. Okay. So now we're going to use a scalar multiplication to find the image KLMN after a dilation with it centered at its origin. So kind of like how we did all our dilations centered at the origin. That's what we're going to do here with dilations. Alright, our rotations were always centered at the origin, so were our dilations. But the scale factor is 1/3, so it's really just going to multiply each point by 1/3. So like, just to show too much work, like K prime is going to be negative 6 over 3, 6 over 3. So K prime will be negative 2, 2. L prime will be negative 3 over 3, 6, 3. L prime will be negative 1, 2. And if you just want to write out the pairs, that's fine. If you can do mental math, like you could say M prime is 0, 1, and then we'll write N prime up here. It's going to be negative 2, 0. Alright, so that's it. You literally just multiply all the points. So now K is negative 2, 2. Boom, that's K prime. I'm not going to write the letters down because it might get a little too tight. I may have to extreme close up. But that's what it looks like. And just to emphasize how it's centered at the origin, again, let's do yellow so it's not standing out too much. But I can go through all these points. These points are collinear. K prime and K prime are collinear. L and L prime are collinear. And they all stretch back to the origin. So it's like the origin is where you're stretching from. Alright, cool. Alright, some coordinate geometry, gotta love it. Alright, let's do this problem now. The vertices of triangle ABC are as follows. So let's go ahead and plot this super quick. We have negative 4, 1. 1, 2, 3, 4, 1. That's going to be A. B is at negative 2, 2. C is at negative 2, 1. Alright, so we got this itty bitty baby triangle. Look how adorable this baby triangle is. So cute. Okay, that's good as it's going to get. Alright, first we're going to translate it. Plus 5, plus 1. So right 5, up 1. So that's where A prime will be. C prime. And B prime. And I think I don't think that's supposed to be a tick mark, but it kind of looks like it, so I erased it. Okay, so we just translated the image right 5, up 1. Now we're going to dilate it with a scale factor of 2. Alright, so A is at 1, 2. So now, see, A is, I didn't write down the coordinate, but it's at 1, 2, so now it's going to be at 3, 6. Or excuse me, I brain farted. Let me write this down. 1, 2. Alright, so that means A prime, the scale factor is 2. For some reason I thought it was 3. It's going to be at 2, 4. C was at 1, 2, 3. 1, 2. At 3, 2. So C prime will be at 6, 4. double prime. This should be double prime. And then B is at 3, 3. So B prime will be at 6, 6. B double prime will be at 6, 6. And there we go. And then just to emphasize, that's stretched back to the origin. Pretty cool stuff. Those green lines you don't have to draw. Alright, now we got some 2 tough logic problems, but it's just good to talk about pure logic. This is a little abstract. But we got segment AB is located at a coordinate plane and has some length of j. Alright, so AB is just some segment and it has a length of j. And j is a positive whole number. Describe a dilation that would create a similar segment with length k, where k is a positive whole number. So A prime B prime has some random length of k. Alright, so remember the scale factor is final over original. That means the final length was k and the original length was j. And really, that's it. Alright, kind of goofy, kind of quirky, kind of abstract, but just a bunch of general numbers. Alright, if you have some length j, you want to make it k, we just multiply by k over j. Alright, and then just to kind of think about it in other terms, some random length, well, what if this was 3 and that was 5? What would the scale factor be? 5/3. Alright, and that's all you really got to do for that one. So even if you wanted to put it in coordinate notation, it'd be k over j, x, k over j, y. And I saw a problem like this on the air test, so that's why we have this right here. And then last problem. Alright, triangle ABC has vertices A, 1, 3, B, 4, 7, and C, 6, 2. After dilating the scale factor by 1/2, find the length of A prime, B prime. Alright. So there's a couple ways to do this. You can multiply the points by 1/2, then find the distance, or we can just go ahead and find the distance, then find 1/2. Alright? And this is why it's good to know the distance formula, because this problem right here, we can't use Pythagorean theorem shortcut because we don't have a coordinate plane. Alright? Unless you want to draw a really detailed coordinate plane, it's going to be hard to do. Alright, so we got to find the distance. Alright, I'm going to label my points. Alright, now I'm just going to plug in my points. Now I'm just going to follow the order of operations. 1 minus 4, negative 3. 3 minus 7, negative 4. Parentheses, now exponents negative times a negative. Remember, squaring any number always results in a positive number, except 0. 0 is not positive. But anyways, that's what we get there. Square root of 25. 5. Alright, so AB equals 5. So A prime B prime is dilated by a scale factor of 1/2. So it just equals 5 over 2. Alright, so we can say A prime, B prime. These are all good answers. I would say 5 over 2, 2 and 1/2, 2.5. Those are all the same thing. Alright, and that concludes these.